Let us first understand the underlying concept of this question. And for that, suppose equals to zero matrix. And remember, the zero matrix is a matrix whose each entry is zero. Both are equivalent. And this is the form in our question. Here there are two matrices, but here we have three. Okay, we will go to these two matrices later. First understand this one. Here, according to question, we have to find a matrix. This matrix. This should be non-zero. If you observe that, obviously there is a solution of xyz, and that solution is 0, 0, 0. If you put 0, 0, 0, then obviously this equation holds good. But that is trivial. According to question, we have to find this matrix a non-zero matrix. Okay, minus 5, 1, 1. Okay, if you put this here, then this will be equal to 0. Zero matrix always satisfies such relations. We have to find a non-zero matrix in both, whether it be a statement P or a statement Q. Now let us one more example. I take this time this matrix of larger size. So this single equation can be equivalently written as, if you take y equals to y equals to z equals to 0, then obviously this value satisfies this relation. We have to find a non-zero matrix. It means that all entries must not be 0. Okay, so if you go to solve this, then you have such a matrix. This matrix satisfies this relation. If you put this matrix here, then this relation holds good. Okay, and you know a is a variable, so there are infinite number of solutions. In the past example also there are infinite number of solutions. What is the reason? Reason is that we have two equations, you see here, but variables are 3. So we have more variables and less equations. Whenever we come across such a situation, then we have infinite number of solutions, and in that case it's very easy to find such non-zero matrix, okay, whose product with a given matrix is 0. So now we have understood the underlying concept. Now we are in a position to solve this question. Here is AZB. I write here. It should be equated to 0, and we have to find, is there any Z satisfying this relation? So first let us see the size. Our matrix A is of size, this matrix 6 into 5, and our B is 5 into 4. So this matrix must be 5 into 5. So in this matrix, you see there is a non-zero matrix. So in this matrix Z, there are 25 variables. Note that this is not a 0, and its size obviously will be 6 into 4. 6 into 4. So this size of this matrix gives us the number of equations. So 24 equations. Okay, so we have more variables, less equations. So we have definitely a non-zero matrix Z, as I discussed in the beginning of this video. Okay, if you come across more variables, less equations, then you have such a non-zero matrix Z. Okay, so our statement P is correct. First we go in the same way. So at this time we have less variables, more equations. So what will be the result? Result will be Q may be true or false. See the options. We have to choose either true or false. Okay, thus we have to see the earlier equation, that is this equation, in a different way. Okay, and this is a zero matrix. Okay, and suppose this ya is 0. If ya is 0, so 0 matrix into b is obviously 0. A different approach to satisfy the same equation, this equation. So here all the variables are in this matrix y variables. Okay, this time this zero matrix is not of order 5 into 5. This zero matrix this time is of order 4 into 5. 4 into 5, that means 20 equations. So again you see, more variables, less equations. Q is also a true statement. Correct option is A.